In this lesson, you will solve systems of linear inequalities by graphing and then apply those systems of linear inequalities. So a system of inequalities is a set of two or more inequalities with the same variables. So example 1, we have two inequalities and they're both already solved for y, so we can very easily graph these. I know in this equation that my slope is -2 and my y-intercept is 1. So I'm going to put my dot at the y-intercept, and this is going to be a fall 2, run 1 relationship. I will use a ruler to connect, and this is going to be a dotted line, because remember, if it is greater than or less than, but not equal to, it is a dotted line relationship. If you have an equal to, then it is a solid line. In this equation, I have a slope of 1 and a y-intercept of 3. So when I graph, this is going to be a 1, 2, 3 and a rise 1, run 1 relationship, and it's a solid line because it is an equal to. Now granted, we want to use rulers, and I know mine's a little bit off. Yours will be better in your notes. So now we work on our shading. I'm only going to shade where the two solutions intersect. So if you look at this first equation, it's everything greater than the dotted line, so that is arrows up. So I would shade everything with the arrows up, but I wait to shade until I see where they would intersect. Then I have less than or equal to this solid line, so I shade everything below. If you can see here, the intersection is going to be right here where the shading up and the shading down meet. So I would shade only what is here. Now, it is okay for you to shade lightly in pencil everything above and everything below, and then when you see the shading intersects, just make that very dark, and then you can go back with your eraser and erase what is not the solution. So this is the solution of example 1. Now you try the example in your notes. Sometimes you will have a situation that looks like example 2. We are going to have to solve for y. So I subtract 3x, and I have negative y is greater than or equal to negative 3x plus 2. I multiply everything by a -1, so this is y. Because I'm multiplying by -1, I flip the symbol, 3x minus 2. So my slope is 3, my y-intercept is -2. If you look, it is going to be a solid line, so I have a -2, rise 3, run 1. And I'm going to connect with my ruler, and it is solid. Now I'm going to solve for this equation, and I'm going to subtract 3x first. So this is -y is less than -3x minus 5. Multiply everything by a -1. So this is y. I am going to flip because I multiplied by -1. 3x plus 5. Now this is dotted. 1, 2, 3, 4, 5. Rise 3, run 1. Now, just because these are parallel, that doesn't mean that it's a no solution. We have to look at the shading first. When we shade our first equation, I'm going to look here. It's everything less than or equal to that solid line. So I'm going to shade everything below. If you look at this equation, I'm going to shade everything above the dotted. As you can see, there is no place where they intersect. So therefore, this is going to be what we call a no solution, and you don't have to do any shading at all. If you have the preliminary shaded, you can go ahead and erase it. Now, if we had a situation, this is what I want to talk to you about. Just because it's parallel does not mean it's no solution. If it is parallel like this and we were shading above the solid and below the dotted, we would have an intersection in between. So I want you to really look at your shading before you write no solution. So you try the example in your notes. All right, our real world problem. Natalie's running for student council, and the election rules say that for the election to be valid, at least 80% of the 900 students must vote. Natalie knows that she needs more than 330 votes to win. So our two situations that we have is the votes that she needs to win. So let's say let X equal the votes needed. And then let's say let Y equal the votes to be valid. So we know that she needs more than 330 to win. So we're going to say X is greater than 330 because X is the vote she needs to win. And if she gets more than 330, she would win. Now, we don't want to put equal there because I think if she has exactly 330, that wouldn't give her a victory. So we just want to say more than. And then our other situation is she needs to have 80% of the 900 students vote for it to be valid. So our validity would have to be greater than or equal to, because that's at least. So at least, what is 80% of 900? Go ahead and do that on your calculator, and you get 720. So 720 students could vote or more to give her a valid result. So as you shade, this is our 330 here, and this is going to be dotted because your X is 330, and we're going to shade what is to the right because that is what's greater. And then we have a horizontal at 720, and that's going to be solid at 720, and we're going to shade everything that is above that. So we get an intersection here, and we can erase then the shading that is not a part of that intersection. So inside this section, we can look for any combination of votes that would work. I'm going to put some votes on your question, and you have to pick something that would be in this shaded section because you worked this example with me in your notes. After you have selected your viable answer, I want you to understand that there could be more than one answer here because there is quite a bit shaded here. So you do the question in the notes, and then you'll try the example in your notes.